covers the topic of antenna handling, rigging and installation for a Ceragon microwave installation project. The agenda of this module will cover the following topics. How to do the equipment inspection and whose role is it? Some general antenna instructions and procedures. How to use the propagation report. How to use a magnetic compass for installation of the antenna. How to hoist, assemble and mount the microwave antenna. Let's talk about equipment inspection and how to inspect the rigging equipment. The rigging team will be responsible for conducting regular checks on their equipment and be fully trained to recognize unacceptable wear or damage to the used equipment. The team should consider these aspects in an equipment inspection. The winch should be serviced at planned regular intervals. The winch cable, made of steel, should be checked for fraying, cuts and kinking. Check wear on eyelets and cable clamps. Ensure the cable is always wound correctly onto the winch drum. The rope, which is made out of fibers, should be checked for fraying of fibers, cuts and contamination from oil, grease etc. or build-up of dirt, grit inside strands. These can cause internal fiber wear. The shackles should be checked for pin or bow wear, thread damage or distortion of the bow. The pulley block should be lubricated if required, checked for wear to the groove, looseness of pins and wear or damage of the pulley groove. Please check if cable or rope is compatible. Let's talk about equipment inspection and how to inspect the rigging equipment. The rigging team will be responsible for conducting regular checks on their equipment and be fully trained to recognize unacceptable wear or damage to the used equipment. The team should consider these aspects in an equipment inspection. The winch should be serviced at planned regular intervals. The winch cable, made of steel, should be checked for fraying, cuts and kinking. Check wear on eyelets and cable clamps. Ensure the cable is always wound correctly onto the winch drum. The rope, which is made out of fibers, should be checked for fraying of fibers, cuts and contamination from oil, grease etc. or build-up of dirt, grit inside strands. These can cause internal fiber wear. The shackles should be checked for pin or bow wear, thread damage or distortion of the bow. The pulley block should be lubricated if required, checked for wear to the groove. Looseness of pins and wear or damage of the pulley groove. Please check if cable or rope is compatible with the groove size. The slings, please check for cuts, fraying and or contamination. Ceragon can and will reject any item of equipment and have it removed from the site if considered unsuitable or unsafe for its intended use. After the equipment has been received on site and the inspection is finished, let's have another look at some safety measures on site. All of the rigging work must be done only by fully trained and experienced riggers. The rigging equipment needs to be approved and in full operating condition. All the rigging workers are supposed to have valid and approved climbing certificates for the country they are working in. This is valid and should be respected in any Ceragon project operations. All of the rigging team should have complete safety-rated equipment. Whenever conducting a hoisting operation for installing or modifying microwave equipment, there need to be well-known communication methods, with pre-agreed signal, that mean the same thing for everyone involved. Do not rely solely on voice. It is just not good enough on windy conditions or zones with lots of industrial noises. As a first suggestion, make sure to use two-way radio communications. Use hand signals, like the ones exemplified here to communicate up, down or stop actions. On tall building or towers especially the use of radio communications should be preferred. If you are using cell phones, ensure full batteries, chargers and credit for everyone in the team. As previously stated, your first and most important help should be reading the user or installation manual of the antenna. Every antenna assembly kit will have clear instructions from the manufacturer. The rigging method should take into consideration the size and complete weight of the antenna or antenna system to be hoisted. Use protection for the antenna and antenna interface steel work from getting in contact with the ground, always. Timber or plastic make a good protection. Thick carton can make for a temporary solution, for short periods. The installation needs to be planned in terms of human resources, so sufficient people need to be present on site in order to cover almost all possible scenarios. Follow procedures. These are essential to your work with antennas. In consideration to the tower interface, it is important to keep the hoisting weight to a minimum. So for large antennas, first assemble and mount the pole mount to the tower leg or to the tower face. Ensure that the mounting pole is vertical, leveled before beginning to hoist and mount the antenna. Check to make sure that all of the bolts are properly tightened. In consideration to the antenna, adjust the feed horn polarity and place a temporary seal over the port. Hoist and mount the antenna. Place the ring stop at the bottom of the pole so that the antenna does not slide down. Perform a coarse antenna alignment using a magnetic compass. Use a spirit leveler on the rear of the antenna to bring it to vertical position. Adjust the tilt of the antenna according to the link budget document and according to your desired RSL level. Use a multimeter connected to the TNC connector on the RFU. Once alignment is done, tighten all the antenna bolts and secure side struts to the tower. Details of antenna height and direction of shoot will be provided in the propagation report for the radio hop. A few things are left to the installation team to decide. Often, the antenna's offset, if the antenna will be mounted on the leg or the face of the tower, and where to anchor side strut. Making the right decisions at this time is important for the long-term integrity of the antenna system. Please pay special attention and confirm details with more experienced teams or colleagues. Using a magnetic compass for coarse antenna alignment is a good way to do it. However, there are some considerations that need to be understood when working with the magnetic compass. The compass can be used to establish antenna direction of shoot, based on the azimuth from your link's budget. Establish where to best mount the antenna, either off the tower leg or on a face of the tower. If the antenna is to be mounted with a left or a right offset. Normally, this is a preliminary step. By knowing all of the above along with the height of the antenna, we can further establish the following. If we have suitable positions available to anchor the antenna's side strut or side struts. If there is any conflict with our currently proposed antenna position. If there is any needs to reinforce or strengthen the tower at the position of the antenna mount. For the latter, the decision can be taken from the site survey if the tower is already built. If the tower is not built, this need can be established from the tower design drawings. But, if used incorrectly, the compass can give wrong information and even lead to very time-consuming and costly adjustments, maybe even relocation of the antenna. That is why we strongly recommend that, before using the compass, make sure you are understanding all of the external influences that can affect your compass readings. To avoid errors, try to have someone do readings in the vicinity of the tower or building, but with less possible interference from any large metal structures. The concept of magnetic declination shows the difference between Earth's true north pole and the magnetic pole. Better said, the angle between the direction of magnetic force in a region of the Earth and the direction of the geographic north pole is called the declination. As the Earth's magnetic field varies over time, the positions of the north and south magnetic poles gradually change. So, the magnetic declination at a given location also changes over time. Please observe the magnetic declination map for our current period, on screen. As the magnetic pole moves across the surface of the globe, lines of constant magnetic declination appear, and these lines are called isogonic lines. Please see these lines along with their respective declination in degrees of variance, either plus or minus, to the true north. For example, the magnetic declination for Romania is approximately 5 degrees plus, while for Brazil is approximately between minus 16 to minus 22 degrees. Sometimes raising or lowering antenna a short distance from its planned position can make all the difference when establishing a good anchoring position for the side struts. And for small distances, the signal fading might not be an issue in comparison to the gained strength. However, consider that there might be antennas planned to be installed just below or above the current position. Moving your antenna can lead to some issues. If you do need to move the antenna, for good reason, Remember, moving an antenna downwards has a higher risk of the radio beam meeting an obstruction and causing signal fading. Moving the antenna upwards has a lower risk as because ground obstructions are normally given greater clearance. Antenna can often be raised higher than the plan, but seek permission first. There will be some extra cost for this movement. This extra cost comes in the form of additional feeder cable, hanger support, additional waveguide, maybe additional connectors in case some have already been used. Make sure you have these available on site before moving the antenna. Remember, once an antenna and feeder are installed, if a movement is needed, an antenna mounted higher can be lowered without too much complication. Cables can be shortened, so can the feeder. A lower antenna can be raised, but will the existing cable be long enough to reach the higher position? Splicing or joining the cables is not permitted because it would add too much attenuation. Therefore, it must be replaced with a new and longer section of cable. Let's look at the most common parabolic microwave antenna components. As a minimum, the antenna should have the following: the main parabolic reflector, to the back of the antenna. The radome, to the front of the antenna, protecting against wind and weather. The feeder system inside, which drives the radio signal from the ODU to the antenna. The feed horn connection, the last part of the feeder system, that reflects the radio signal back to the reflector before going out. A shield between the reflector and the radome, sometimes with absorbing foam. Bolts and nuts for clamping the various parts. Some antennas might have a lower side part, for absorbing some wind, inside to counteract against the wind coming towards the radome. The antenna design varies from manufacturer to manufacturer. This results in changes to the assembly procedure of the antenna, the dimensions and the weight of the antenna. Before installing any antenna, always read, understand and follow the assembly and installation instructions. These should be contained in the bulletin delivered with the antenna on site. Make sure you confirm the dimensions and the assembled antenna weight before hoisting. Antenna. The antenna. Let's look at the antenna, lubricants and torques. Correct antenna assembly is necessary to guarantee long-term stability throughout its operational life. To obtain that, pay special attention to achieving the correct arrangement and tightening of all bolt fasteners. Follow strictly the instructions provided with the equipment in the form of drawings and bulletins. The antenna manufacturer will provide torque data for each type of bolt fastener, so make sure you use it. Even before the actual assembly, become familiar with the proper application of greases, lubricants and thread locking compounds, like Loctite. These are used on a number of Ceragon components such as gaskets and bolted fasteners for antenna, for the ODU, the branching box and the waveguide assemblies. Full instructions are provided with each assembly bulletin. Apply as instructed, and use only where stated. Since we mentioned the various components that have threads and need to be tightened, let us spend some time to look in more detail at this. For one, the functions of a thread assembly are to create a clamp force, to maintain that clamp force and to also allow disassembly later. So the question arises, why do threaded assemblies fail? The clamp force is not maintained and the threaded assemblies loosen because of a couple of things. The existence of gaps. To make the assembly possible, the nuts and the bolts must have some tolerance, which creates gaps between the threads. Vibrations and side-to-side movement. These gaps allow the parts to move from side to side when exposed to vibration. Expansion or contraction and loosening. The expansion and the contraction can also cause side-by-side movement. This, in addition to vibration, leads to loosening and ultimately disassembly of parts. Disassembly is not always possible, because in certain conditions the nut and bolt can seize together. The initial seizing can then lead to corrosion or rust, when dealing with humidity, high temperatures, assembly of different metals, for example galvanic corrosion. Galling, that is welding of two objects by friction. How does a thread locker work? Thread lockers are single-component adhesives that cure in the absence of air, and in contact with active metal to form a tough thermoset plastic. They completely fill all voids between the interfacing threads, which makes the assembly an unitized component, prevents any movement between threads, and ultimately prevents loosening. How do I use a thread locker? To achieve optimum performance, all parts must be clean and free of contaminants, like oil, dust or grease. Then the material needs to be added on the bolt in a slim pellicle. In case of through holes, the thread locker needs to be applied on the other end as well, just before the nut coming to tighten it. Post-assembly product can also be used, just after the nut was tightened to the rest of the bolt. For blind holes, the thread locker can be poured inside the hole. Here, to the left, you can see some typical properties of the thread locking fluids depending on their color. Installing an ultra-high performance antenna requires attention to some uncommon aspects. For example, the dual polarized feed horn for some UHX antennas produce asymmetrical radiation patterns that have a lower energy emission on one of the sides. In our example, the Andrew feed horn show has the better side marked in red, which, when installed to the left or right, can reduce any potential interference from that side. If a better side has been specified, please ensure that the feed horn has been correctly oriented before beginning to align the antenna. Please observe the antenna radiation pattern of such an antenna, for example a UHX Andrew antenna. This shows significantly less power on the right side of the screen. Such an asymmetrical pattern can be used to lower interferences with other antennas installed on the same location. For example, imagine a second antenna installed at 90 degrees orientation to the right side from the current antenna, with its asymmetrical pattern oriented left. Even in a rough comparison, you can see a difference of radiation or energy concentration on the two principal side lobes. The left and the right one show a difference between values of 3 decibels or more, which is twice the power or even more. Such an arrangement would decrease the interference to an antenna placed somewhere close the end of our current link, to the right side of the far end antenna. What is an antenna offset? Offsetting antenna is simply orienting the dish either to the left side or right side of the support column or mounting pole. This will not affect in any way the antenna's polarization. The offset option allows us to obtain the best position to align the antenna, because it gives more options to stabilize the antenna with the metal bars called side struts. The antenna offset can simplify feeder installation and can make future maintenance access easier. For example, the antenna is mounted closer to the access ramp or ladder. With the large diameter antenna illustrated above, this is accomplished simply by adjusting the mount frame at the rear of the antenna. Please note, in this example the main antenna dish is not rotated. However, this can vary from manufacturer to manufacturer. In order to offset a smaller antenna, like the 0.3 to 0.6 meters antenna, there are a few considerations to be looked at. The offset is the actual placement of the smaller antenna to the left or to the right side of the mounting pole. Please note that in this case, even though the offset is changed, to better suit the wind conditions, or simply fit another position, the actual polarity of the feed horn remains the same. So a feed horn oriented for vertical polarization will remain on the same polarization with the exact opposite antenna offset. When properly mounted, the antenna and tower effectively integrate into a single unit. The side strut, a resistant metal bar, placed between the offset of the antenna and the tower, secondary to the pole mount connection. This side strut is aimed at enforcing the connection between tower and antenna, by transferring some of the wind load directly to the tower, without pole mount mediation. Side strut or struts mounting angles are very important, because if the strut angle is sharp, there is a great chance that the wind load will be stronger than the antenna system's wind resistance. This is visible especially at connecting joints, causing the bolted connections to move and rotate and finally allowing the antenna to move. If the side strut is angled correctly, it will result in the whole system successfully overcoming the wind load without antenna to move. How to determine the strut orientation. Suitable mounting points must be provided on the tower or main support structure prior to installation of the azimuth, both for the adjustment strut and the fixed strut, if required. For structural efficiency, the struts should be installed parallel to the antenna axis, that is bore sight. When it is not possible to mount the struts in this manner due to tower or outrigger considerations, the struts may be positioned anywhere within an angular cone relative to the reflector axis. You can see this in the displayed diagrams here, in our slide. Please note the radius of the movement recommended for each of the side struts. Installing the side strut or side struts parallel to the bore sight of the antenna will provide optimum stability for the antenna by transferring wind load to the tower structure. Firstly, from the top view, you can see the azimuth strut arranged parallel to the antenna bore sight, while being fixated to the left side of the antenna. At the same time, the fixed strut is also parallel to the antenna bore sight, to the right of the antenna. Secondly, from a side view, again, you can see the two side struts in parallel arrangement to the same antenna. The side strut or side struts will only support the antenna effectively if they are installed within the angular limits stated in the bulletin delivered with the antenna. Please refer to the manufacturer's installation notes and keep in mind the previous slide discussing the angle for installation. As always, the manufacturer's instructions must be followed. Otherwise, signal fading and possible antenna damage can result, compromising the installation project. That is why we strongly recommend that before installing an antenna, you establish where the side strut or side struts will be anchored to the tower structure. Ensure that the side strut bracket assembly is suitable for the size of the tower member. Confirm that the bracket assembly can be rotated to suit the angle of the side strut. To ensure that future issues are avoided as much as possible, all bracket assemblies must be manufactured from high-grade steel and hot-dipped galvanized. Should an antenna fail, Ceragon may become responsible for the repair and replacement costs, financial penalties and even other liabilities. In such a case, the customer loses revenue. Ceragon may lose a customer. Let's look at some basic antenna data. In this table, we can see a list of common antenna diameters, along with the tube sizes to be used, the azimuth adjustment range, the elevation adjustment range, the survival rating for wind load in kilometers per hour, the antenna net weight in kilograms, and whether RIF needs a mandatory side strut or not. In the last column you can see the dependency between antenna size and the number of mandatory side struts. Please note that the initial course antenna alignment should permit panning within the adjustment range of the hardware. The riggers must know the weight of an antenna assembly before hoisting. Example data only is shown here, but keep in mind some other weights need to be calculated from the rest of the components, side struts, pole mounts, mounting brackets, etc. From the example table, not that mandatory equals minimum. The antenna may require more side strut than shown here under some conditions, like very strong winds. The question of tower real estate comes into discussion at this point. The installation team needs to understand that tower space is limited. To this point, the space on the tower needs to be respected as per the installation plan, without much wiggle room, so do not waste tower space. Take this example, observed from above the tower, looking down, and keep in mind the following aspects. Tower space is very valuable space, because it is limited. The side strut or struts are to be kept within the manufacturer's angle limits. Try to be considerate of future antenna installation and not cause obstructions. It may be you who needs to install on the same tower. Make your life easy in that respect. After correct installation, cut the side struts to keep the climbing area clear for future teams. Any exposed cut will need to be prepared with zinc-rich paint compound to avoid corrosion. In projects where multiple side struts are used to stabilize an antenna, it is vital that positions are established on the tower where these can be anchored before attempting to install the antenna. Better safe than sorry, so install it right from the first time. Better to measure a few times and then cut and install than being hasty and wasting materials. In order to avoid injuries on the installation site, in respect to the climbing space, always try to keep the climbing area inside the tower free of obstructions that may inflict injury. Plan carefully how the antenna should be mounted onto the tower. Prepare a correct offset on the ground rather than trying to make changes after the antenna has been installed. Please observe the animation showing such a scenario, which can be problematic if not thought about ahead. In terms of antenna offsetting, let's consider these following points. Wherever the antenna bore site aligns close to the diagonal of the tower, or perpendicular to the tower face, offsetting either left or right might make very little difference. In such a scenario, the choice of installation position should be based on finding the optimum feeder run, finding the best side strut anchorage points and clearance of the service access. Using a short side strut arrangement will provide better stability if a solid anchorage can be established on the tower structure. Long side strut will obstruct future antenna installation. Let's have a look at a wrong choice of offset to learn from such a mistake. Wherever the antenna has been offset too far from the tower, it becomes difficult to stabilize against wind, as fewer options remain available to anchor the side strut. High wind speeds will increase antenna movement, as is expected. In terms, the antenna movement will increase signal fading on the link. Antenna movement may even loosen or damage side support arm linkage. With an arrangement such as this, finding a solution to also supporting the feeder cable becomes complicated and costly. Another consideration is that the service access to the antenna has, now, increased risks because of the big distances to the tower. Based on our discussed points, the actual example from the right side of the screen was rejected. How to get is wrong. It's not that difficult actually, so let's see how that can happen. In this slide you can see some of the most common errors during this process. The side strut angle is very sharp on the tower side and very open on the antenna offset side, so it's easy to understand that this strut does not do a good job of transferring the wind load to the tower. The antenna azimuth is inoperable from this angle. It cannot be used to pan the antenna for better signal. The antenna offset should have been done to the right, or antenna should be moved to an adjacent leg. The side strut should have been positioned on the rear frame, but on the other side. You can easily see that maintenance access to antenna is very difficult if this mounting is used. One other thing to observe, that the waveguide required extra standoff support. From the example, you can see that placing the antenna about 20 centimeters lower would have allowed a better positioning for the side strut to fall perpendicular to the tower, which provides better wind support. The employment of a side strut is not for its full length. There is a redundant part to the side strut, as visible in our animation. This part is normally getting cut, but only after final alignment. Also, another smaller part is left after the mounting bracket, some 20 centimeters, just in case there would still be a need for further movement or the fixation was not done properly and there needs to be an adjustment done. After final mounting position and alignment is done, the strut can be cut. The cut should be done with a good hacksaw blade, in order to ease the process. It can take a couple of minutes to do the operation. If you must cut a side strut, always seal the end with zinc-rich cold galvanizing compound. Be careful not to use aluminum paint or gray paint or silver paint, but cold zinc galvanizing paint. What's the difference between them? How does cold galvanizing zinc paint work? The cold galvanizing zinc paint is an organic, single-component zinc coating of minimum 92% weight, zinc in the dry layer. It acts as an active coupling to the steel parent metal to form an electrolytic bond, protecting that surface against corrosion and contamination from other substances. Another, very important part when dealing with antenna mounting is the stop ring. The stop ring is just a simple ring set at the lower part of the mounting pole, that helps keep the antenna in place before alignment and final fixation. The stop ring provides a platform to rotate the antenna and additional security preventing antenna slippage down the column. Installation tip. Some antenna mount may not rotate smoothly over the stop ring when panning the antenna. This can often be overcome if the antenna direction is perpendicular to the stop ring joint. A stop ring may not always be provided with every type of antenna. Always use the stop ring if this is included with the antenna kit. Before fixing the stop ring, decide first at what height the antenna should be on the column. Minor vertical adjustment of the stop ring should be considered if side strut limits are difficult to achieve or side strut brackets cannot be positioned to suit the side strut angle. For waveguide, ensure there is sufficient space for connecting to the feed horn and tolerance to pan the antenna. For those antenna not provided with a stop ring, it is important to set the direction of shoot as accurately as possible to ensure that the received signal can be established within the panning limits of the antenna. The antenna pole mount or column verticality needs to be established first, before antenna mounting. A tool called spirit level can be used for the job. The tool needs to be inspected prior to the installation, to make sure it works properly. The check consists of different measurements done across the sides of the pole mount. First, check along one side, then move the spirit level around the column and check again and again. If the pole mount is not vertical, it is important to correct this before installing the antenna, otherwise some difficulty can be experienced when panning the antenna. Once the check is complete, and the pole mount is vertical, check that all of the bolts are correctly tightened and secured in place. The feed horn port or ports need to be kept sealed at all times until terminating the waveguide. For the dual polarized antenna with dual feed horn where only one polarity is used, a termination load should be fitted to one unused port. See the example above. It is important to fit a gasket kit to obtain an air, watertight seal. The installation of the termination load should be done at ground level, before hoisting the antenna up the tower. Things to be aware before hoisting the antenna. First of all, there should always be some protection between the antenna and the ground surface, as discussed before. At all times of the installation project, neither the antenna nor other components used should be in direct contact with the ground. One important observation for the antenna on the ground: do not place any of its load on the weaker, front edge of the antenna. That part is to be kept clear of the ground. This is exemplified in the right side diagram. Secondly, before hoisting an antenna, the team should double-check all rigging equipment, knots, pulleys, shackles, etc. You could use the knowledge of more experienced people when doing this. Thirdly, check to make sure the ground-to-tower communications is operating without interference. Next, attach ropes to prevent the antenna spinning during hoisting. The lower rope, attached for control, is called a pay rope. Use 2 separate ropes, one each side of the antenna if better control is needed. Installation team needs to deploy enough personnel to control this pay rope that prevents the antenna striking the tower or other antenna and also prevents rotation of the antenna. Next, prepare the sling positions for raising antenna. To have a good understanding of this, refer to the antenna installation bulletin. Make sure that the sling arms are not at more than 90 degrees apart before attaching it to shackle. Before hoisting, make sure that the rope and sling weight ratings are higher than the complete antenna system weight. Secure raising rope connected to the sling and the upper part of the antenna with another rope to prevent antenna rolling forward. Raise antenna carefully while constantly communicating with upper team about obstacles. Hoisting the antenna considerations. When hoisting, manually loop the free end of rope through a safe anchor point to break the load and support it in case the hoisting is halted or those hoisting the antenna need a rest. The pay rope should be looped around a tree or removable object a distance from the tower approximately equal to the installed height of the antenna. The rope needs to be controlled by one person at all times. If you are using a winch, then make sure it is well restrained against any movement. Mounting larger antenna at the very top of a tower can be difficult and risky if the right equipment is not used. It is important to position the pulley block as high as possible above the antenna. The recommendation here is to always use a well-designed gin pole to minimize the risk. A gin pole is a supporting pole mounted at upper side of the lifting position which uses a pulley or block and tackle on its upper end to lift loads. The lower end is braced or set on the tower in a special hole and positioned so that the upper end lies above the object to be lifted. Sometimes, the weather is very unsuitable for the use of microwave machines and antennas for longer periods of time. Please consider the first picture and understand that there are lots of zones in the world where this can be a real issue. More to this, ice from the tower can fall and break or damage the antenna, the connections, the waveguide or the RFU connectors. To avoid such a falling ice scenario, we recommend our clients to employ the use of icebreakers and ice protection solutions. To the right side of the screen, you can see an example of properly used ice and snow protection, or breaker. The table also shows you the list of possible icebreakers that can be purchased from Ceragon. Before considering the installation project finished, let's do a checklist summarizing the most important aspects discussed. It is important to set out accurately the antenna's direction of shoot using a magnetic compass, with multiple measurements done for accuracy. A decision needs to be taken whether the antenna is to be leg-mounted or face-mounted. Choose which antenna offset will provide best option for antenna stability. Confirm the antenna can be rotated through azimuth without any conflicts. Clear obstacles or mount the antenna outside their reaching. Ensure that side strut will have good anchorage and will not exceed angle limits. Decide if additional structural struts are needed for antenna stability. If permissible, raise or lower the antenna to establish a better position, but seek permission first. Keep antenna pole mount as close as possible to the tower and in vertical position. Ensure that the waveguide will not be in conflict with structural members. The agenda of this module has covered the following topics. How to do the equipment inspection and whose role is it? Some general antenna instructions and procedures. How to use the propagation report. How to use a magnetic compass for installation of the antenna. How to hoist, assemble and mount the microwave antenna. Thank you for your attention.